Let V in is equals to 10 volts and RL is equals to 10 kilo ohms. RL nothing but load resistance. Output resistance is known as a load resistance. V in is equals to 10 volts and RL is equals to 10 kilo ohms. 10 kilo ohms. In that first question, if barrier voltage is 0.7 volts, barrier voltage is 0.7 volts, then find, in that first question, again first question, in question 1 only, again A, question A, output voltage across RL, output voltage across RL, output voltage across RL. In that second question, current in the diode, current in the diode. Then third, in the first one, forward resistance, forward resistance. Forward resistance. Rajul, DC Pandey book తీసుకురాపో ఫాస్ట్ గా వెళ్ళు. You draw the diagram. Still question is there, I will tell you. Still second question is there in that, I will tell you. Next question in that, if diode is assumed to be ideal, if the diode assumed to be ideal, then what will be the output voltage and output current in the diode, and output current in the diode. You do one thing, you change the value to the 10.7. I said 10 I guess. V in is 10 I said, no? That will be little difficult for the calculation. You take it as 10.7 volts.
And what will be the
output current? Output current in the diode, output voltage and then output current. First question is what I asked? Output voltage. Now I said already you have to mainly observe that is in forward bias or reverse bias. If it is in reverse bias, nothing will happen in this circuit. So they said it is in forward bias. Obviously the positive terminal is connected to the p type here, so that forward bias. Then after that you have to check the barrier potential. The barrier potential is how much here? 0.7. Applied voltage is how much? 10.7. So output voltage is how much? V out is equals to 10.7 by the minus 0.7. You have to take always the external voltage minus the barrier potential. Then what is the answer you will get here? 10 volts is the answer. Then second question is what I asked? Current. Current flowing in diode. So that current flowing in diode nothing but before that you have to find out the resistance of the diode. Yes, so forward resistance I did not ask that. Third question, forward resistance. So that current I you have to find out. To find out the I, first of all you can either find out the forward resistance, otherwise current directly. So here current is equals to I is equals to what will get here? I is equals to V by R. Voltage is how much we are getting? 10. That divided by resistance is how much here? 10 kilo ohms. Then how much you will get here? 1 milliampere. Yes, that is the current, output current. Then forward resistance. Forward resistance nothing but RF, already we know the formula. V by VF by IF. Correct? VF is how much? You have to take only 0.7 here. Why? Because diode is having how much potential here? Only 0.7. The resistance belongs to diode, so that everything should belongs to diode only. The voltage and then current should belongs to diode only. So here forward voltage is how much here? 0.7 by current is how much we got? 10 power minus 3. Then how much you will get here? 700 ohms. That is the forward resistance. Next second question is the diode is ideal. Whenever the diode is ideal, current and then voltage through the diode is how much? It will not take anything. It will not take anything, it will just passes the current. So in that first question what I asked? Output voltage. Yes. V output is how much? Tell me now. See that 10.7 is the input voltage. Diode is not taking the any voltage nothing but what is the answer you will get here? 10.7 only. 10.7 as it is whatever the input I have given that will give you the output. Then after that question B is what? Output current. Yes, V out is equals to I out is equals to output current is equals to what is the formula for us? Voltage by resistance only. So that voltage divided by the resistance, voltage is how much we got? 10.7 and the resistance is 10 kilo ohms nothing but 10 power 4 I will take. Then how much you will get? 10.7 into 10 power minus 4 amperes. Otherwise I can even write that as 1.07 milliamperes. Anything is correct only. These are the all the answers. How many of you got correctly everything? Yes, good. That is about the PN junction. Next we will discuss the rectifiers. Rectifiers. ವಾಟರ್ ಟೇಸ್ಟ್ ಏನು ಚೇಂಜ್ ಆಯಿತಾ? ಚೇಂಜ್ ಆಯ್ತಾ ಅಣ್ಣ? ಆ ಥರ ಅನ್ನಿಸ್ತಾ ಇದೆ. ಯಾರಿಗೆ? ನಮಗೇನಾ? ನೋಡಿ ಫೀವರ್ ಇದೆ ಅಂದರೆ ಕೂಡ ನಾನು ಬಂದು ನಿಮಗೆ ಟೀಚಿಂಗ್ ಮಾಡ್ತಾಯಿದ್ದೀನಿ ಅಂದರೆ ನಿಮ್ಗೋಸ್ಕರ ತ್ಯಾಗ ಮಾಡ್ತಾಯಿದ್ದೀನಿ, ನಮ್ಮ ಲೈಫ್ನೇ ತ್ಯಾಗ ಮಾಡ್ತಾಯಿದ್ದೀನಿ ನಾನು. ಏನೋ ಅಂತ ಇದ್ರು ಕೆಲಸ್ತಾ ಇದೆ ನಮಗೆ. Right, rectifiers. What rectifier will do? What rectifier will do? It will take the AC signal and then converts to DC signal. Alternating current it will take and then it will convert to the direct current. So in alternating current what happens? Nothing but what is the alternating current I said? It will changes the direction and then magnitude with respect to the time. Whenever you come to the DC direct current, it will not change any magnitude and then direction with respect to time, it will be constant. So that is about the DC. and we have discussed that power losses and all, whatever the power factors and all, that is already finished last week only. Now here rectifier nothing but what rectifier will do means it converts AC signal into the DC signal. Then how DC signal will be converted to AC signal? How DC signal will be converted to AC signal? Huh? I said yesterday, I think in one of the section I said that inverter. We'll use the inverter to convert that. We'll use the inverter. I said no yesterday already. ಅವಾಗ ನಿದ್ದೆ ಮಾಡ್ತಾ ಇದ್ರು ಬ್ರಹ್ಮಾನಂದಂ ಥರ. Section B I said I think. So here whenever you are converting signal from AC to DC, then you have to use the rectifier. Rectifier you have to use so that we can convert AC signal into DC signal, and also it cannot be converted 100% purely. For that again you need the filter circuits. What filter circuit will do means first of all I'll just tell you the rectifier what it will do. I have taken the AC signal like this. Then whenever I have given this signal to a rectifier, at that time it rectifies the AC, nothing but it filters the AC, and it will gives you the DC output. DC output nothing but what you have to get, straight line like that you have to get. No, here you will not get a straight line. It will be almost like a sine wave only, but it will take only half will be filtered like this. Like this you will get. This is for the full wave rectifier. Half wave rectifier nothing but it will just filters only half of the cycle. That will be types of the rectifiers. Now this is not completely DC. You cannot say that DC nothing but what you have to get, directly like this you have to get, a straight line you have to get. But now we are not getting, that means it is not completely filtered. Nothing but its efficiency will be only 81% will be there in the case of full wave rectifier. In the case of half wave rectifiers it will be 40% only, 40.6%. So efficiency should be 100% actually, but it is less than 100%, so only the signal is not converted to DC completely. Then completely converted to DC. So it is having only 80% of efficiency. After that again you have to filter that remaining AC also. For that we will use the filter circuits. Here the filter circuit will be even that is a capacitor circuit, that might be inductor circuit, as per the requirement you will use. What capacitor will do? Generally what capacitor will do? Stores the energy, right? So it will store the AC energy only, alternating current energy only. So what happens nothing but the capacitor, if I connected in the filter circuit after the rectification, then what happens, it will store the AC, whatever the AC coming, it will grasp that AC and then it will leave the DC. So that DC will be pure DC at that time. So that is how the filter circuits will work, and then that is not necessary for us, but you should have idea about that, what happens in that mechanism, you should have idea. So here rectifier nothing but what it will do, it will convert AC into DC. Now we are having mainly two types of rectifiers, one is a half wave rectifier, another is a full wave rectifier. So I'll just make you as a table and then I'll explain you why, because much depth is not necessary. So here mainly in that rectifier what happens nothing but in half wave rectifiers only one diode will be there. One diode is there nothing but one diode is responsible to filter only one half cycle. Two diodes are there nothing but it will filter the two cycles, and also one more rectifier will be there, that is a bridge wave rectifier. So bridge wave rectifier is same as a full wave rectifier only. Now here half wave rectifier nothing but it will have how many diodes? Only one diode, and then full wave rectifier nothing but two diodes will be there. In the half wave rectifier how it will works means, whenever I have given the AC signal to the half wave rectifier, at that time at a time it will filter how much I said, how much cycle I said, only half cycle. It will filter only positive half cycle whenever it is forward biased. It will filter the negative half cycle whenever it is in reverse biased. So that is how only half of the signal only gets rectified in the case of half wave rectifier. So how you will get the resultant means, after the half wave rectifier you will get like this, only positive half is filtered here. Then whenever you get the positive next cycle, next positive next cycle, next half cycle like that. So only positive half gets rectified in the case of forward bias. Whenever I take the reverse bias, at that time what happens, the remaining half cycle also will get rectified. This is the output of half wave rectifier will take. Then full wave rectifier nothing but the full wave rectifier will have two diodes. The upper one diode is responsible for the positive half cycle, lower diode is responsible for the negative half cycle. So only in the full wave rectifier, complete wave gets rectified. Complete wave gets rectified. So only let me give the numbers 1, 2, 3 like that. First half cycle here, this one is the first half cycle. Second negative half cycle is this one, and then third half cycle is this one, like that. Full wave rectifier contains two diodes. One diode will be responsible for the positive half, another diode is responsible for the negative half cycle. In the case of half wave rectifier, it will rectify only one half cycle at a time. In forward bias only positive half cycle, in reverse bias only negative half cycle. And also in this again RMS values will be there, DC values will be there, everything will be there. You have to remember that. Even the efficiency will be there, and efficiency is important. For the half wave rectifier, efficiency is 40.6%. Just remember it as a half wave, nothing but it should be near to 50. Near to 50 nothing but that is 40.6. Whenever you come to the full wave rectifier, double than that, how much that will be? 81.2. Everything, each and every value will be just 2 times of the, just half of the full wave rectifier. For half of wave rectifier, if you see, that will have exactly half of the full wave rectifier values. Whenever I give the table, in that I will explain you clearly what happens and all. You just draw that table. Full wave rectifier one side, half wave rectifier another side. Questions asked very rarely based on this, but all the values are easy to remember. First and foremost, you write the rectifier. Rectifier converts AC signal into DC signal. Converts AC signal into DC signal. Converts AC signal into DC signal. In the next line, the DC signal will be converted to AC. The DC signal will be converted to AC by using inverter. By using inverter. Draw the circuit, everything as it is. I will explain each and everything. Able to see this last? No. Harihara students ಬಂದಿಲ್ಲ ಯಾರು? No one came. How is Aishwarya? She is okay ನಾ? ಪೇನ್ ಇದೆ ಅಂತನಾ? ಏನೋ ಬ್ಲೀಡಿಂಗ್ ಆ ಥರ ಏನೋ ಆಗಿದೆನಾ? ಹೆಡ್ ಕೂಡ ಎಲ್ಲರೂ ಓಕೆ ಅಂತನಾ? ಫೋನ್ ಏನೋ ಮಾಡಿದ್ರೆ ಎಲ್ಲರಿಗೆ ಹೆಡ್ಏಕ್. ಇದಾ 9/2ನೇ. ಹಾಂ, 2. 0.482. Check all the values again. I have added something in between. Finished, huh? Make it fast. And this most important thing is about the efficiency. Efficiency is very, very important. Shall I? See that in the half wave rectifier, I said that in the half wave rectifier, how many diodes will be there? Only one diode will be there. That one diode will rectify only half of the signal, half of the input signal. This is in forward bias, nothing but it will rectify only first half, and then if it is in reverse bias, nothing but at that time it will rectify the second half. How it will be forward and then reverse biased means, here by using the transformer, what I have given here, AC signal. I have used here step up transformer. Input voltage is less as compared to the output voltage here. So whenever I use the step up transformer, immediately here what is going, nothing but here AC signal is going like this. Whenever first of all positive half cycle is coming, at that time only it is conducting in which bias? Forward bias. So only positive half cycle is filtered. Then whenever the negative half cycle is entering into that, at that time it will be in which bias? Reverse bias. At that time it will filter the negative half cycle, then positive half cycle, then negative half cycle, like that. So whenever you compare the input and then output signals here, completely the diode is in forward bias only, so only it is converting only, it is taking only positive half input and then positive half input here. Clear? That is about the input and then output diagrams. Here negative half is not filtered, but it will be filtered whenever the diode is in reverse bias. So then next one is the transformer used here is step up transformer. We know already, I have given the signal as how much, V is equals to V naught sin omega t. In that peak value is how much here? V naught is the peak value. Then DC output voltage will be how much, nothing but you have to do the integration again. What is the I average formula? Do you remember that I average is equals to integration of I dt by integration of dt. Okay, now you have to apply only for the half of the cycle, half of the half wave rectifier. At that time we will get how much output, nothing but here I naught by pi. Generally what is the answer you will get? 2 I naught by pi. but we are calculating half for the half cycle, nothing but at that time I naught by pi or V naught by pi. Then RMS value will be, again what is the formula for the RMS? Integration of I square dt by integration of dt. There what we will apply, nothing but we will apply the limits from 0 to t. Here you have to apply 0 to t by 2, then RMS value you will get as I naught by 2 and then V naught by 2, RMS values of current and then voltage. Then next one is output voltage. Output voltage is nothing but the output voltage or DC voltage is equals to the output current, output current means output voltage by the resistance only. Here I have one load resistance, okay, RL is a load resistance here. Then what is the RF here? What is the RF here? Forward resistance. Yesterday while teaching the problems I said that you just remove the diode and then keep a resistor here. Whenever they asked about the resistance, diode will also have the resistance. To decrease that resistance only, what we will do, which process we will do? Doping. By doping what we will do? We will improve the charge carriers, so that what happens, resistance will get decreases. So here the current is nothing but the voltage by resistance only here. The voltage is V naught and the resistance is in which combination here? This and then this series combination. So only I have taken RF plus RL. And then ripple factor. Ripple factor nothing but how much it can reduce the ripples. Ripples nothing but AC, we can call as ripples nothing but that is the AC signals. Inside AC impurities will be there. So like the form factor and then peak factor, the ripple factor also one formation will be there. In that we will get the formula under root IDC square minus IAC square minus 1, like that we will get one formula. But the value is constant only, however, always factor value will be all constant only, it will not changes. So that ripple factor value is 1.21 here. Then next one is form factor. Already we know the form factor. What is the formula of form factor? IRMS by IDC. From that whenever I substitute that values, we are getting here pi by 2 as answer. What is the pi by 2? Nothing but I think 1.5 3.14, no, you will get 1.5 like that, around 1.51 like that. So that is a form factor. Next, efficiency. I said half wave rectifier nothing but you have to go to near to the 50. So how much efficiently it can rectify? Nothing but only 40.6% of efficiency. So efficiency formula is what generally for us? P output by P input. Output power in terms of current. Power formula in terms of current. I square into R only. So that output current into output resistance by input current square into input resistance. Why? Because we know the power formula. Power formula is equals to I square into R. I said that output power. In output power how much current is there? I output, otherwise I naught is the current, output current here. Who is the output resistance here? RL is the output resistance. So only I have written as I square DC, otherwise I square output into RL, that is output power. Input power. Input power nothing but we are having the AC input current, and then for the input entire circuit we are having the resistances as RF plus RL. I square AC into RF plus RL, and the efficiency percentage is how much? 40.6. This is important. This percentage is important. Only one time they asked about the resistors, this one rectifiers. Only one time they asked. But whenever you have idea about this and then how to do the problems and all, that problem also very easy. They have given the signal and then they have given to find out the output signal, that's it. They have given one circuit, in that they asked to find out the output signal, that's it. Mainly you have to identify that as a which wave rectifier, and then from that you can get the output signal. I will give you that problem also. That a question asked in the JEE also and then NEET also. Then next one is ripple frequency. Ripple frequency nothing but I said already, whenever you compare the input and then output, output is not completely DC. Output is not completely DC. So that output signal also will have some frequency. Why? Because how much efficient it is doing it? Only 40% efficient. So what happens? Nothing but still AC is there. How that AC will be removed? I said by using the filter circuit. By using the capacitor circuit, we have to remove that AC from that output signal. Now, in the ripple frequency nothing but output signal also will have some frequency. That frequency is exactly same as the input frequency. Input in this how much frequency? For example, if I say frequency is 50 Hertz here, then output frequency also how much here? 50 Hertz only. Whenever it is completely converted into DC, at that time what is the frequency? 0 is the frequency of DC. DC will not have any frequency. Why? Because it is not at all depending on the time. If it is depending on the time, then only frequency will be there. So it is not completely converted to DC. So only it is still having some frequency. That frequency is same as the input frequency. That is a ripple frequency we call. Then ripple nothing but just AC impurities only. AC signals will be there still in the output. That is the ripple we call. Then whenever you come to the full wave rectifier, for the full wave rectifier will take the center tapped transformer. Center tapped nothing but some of the output signal will be given to the transformer again. That is known as a center tapped transformer. So here see, whenever you see here, this is a connection I have. This is my output actually. I am giving that some of the output to again what? Again transformer only, in middle we are giving. So only we know it as a center tapped transformer. How much it will rectify? Full cycle it will rectify. So only for the positive half cycle and then for the negative half cycle I am getting like this. Why I am getting only above? Why I am not getting below? DC will not have any dimension, any directions. It will have only straight line like that only with time. So it is not completely converted. So only we are having still like AC signals only. It will not have any negative cycles and all. Then next one is center tap transformer we will use. Peak voltage is however how much that is. VAC is equals to what is the formula? V0 sin omega t. From that V0 only the peak voltage. Now for the full cycle, whenever you see the average value nothing but you might be think that for the full over the full cycle it is 0. Yes sir. But here in the output how much we are getting? 1 half, 2 half and then 3 half like that. So for the half cycle what is the average value? For the half cycle what is the average value? 2 I naught by pi only. That is what I am getting here. 2 I naught by pi and then 2 V naught by pi. Then next one is RMS. Already you know the formula of the RMS, I naught by root 2 and then V naught by root 2. Then from that again output voltage. Output voltage is equals to V naught by RF plus RL. Why I am getting only one RF? Actually 2 resistors we are having, no? 2 diodes we are having. So 2 resistors we have to get. Then why I am getting only one RF here? At a time only one diode will conduct. For the positive half cycle, upper diode will take the responsibility and then it will filters and then it will give the half cycle. For the negative half cycle, this one will be off and then this one will conduct. At a time how many diodes are conducting here? Only one diode is conducting. So only you will get V naught by RF plus RL. Then form factor already we know the formula and then we got that IRMS by IDC. And then efficiency is how much efficiency? Exactly double than that. How much that is? 40.6 nothing but 81.2 is the efficiency. So 0.812 into output resistance by input resistance. Total input resistance is RF plus RL. Then that is about the again power formulas I have taken. Then after that ripple frequency. Here ripple frequency is same. In the full wave rectifier it will be one diode is same nothing but 2 diodes will be double obviously. So the double of the input frequency. Then next one is ripple factor is here 0.482. Here the ripple factor is how much? I said 1.21. Where is that? 1.21. Clear? That is about the half wave and then full wave rectifier. In that mainly you have to remember about the efficiency. Everything is easy only but just remember these values and then these values. That's it. In half wave rectifier only there is a change in the average and then RMS. In the full wave rectifier already we know in the AC only all the formulas are same. Clear? So main difference is about this and then about this ripple factors and the frequency you can remember easily. And then this one already we know everything. Whenever you know the values of average and then RMS, already you can calculate the form factor. Peak factor. What is the peak factor means? Maximum value by RMS value we will take. Maximum value I naught by IRMS we will take. So that is about the peak factor. And the efficiency is important. Efficiency formula is important here. Whichever I just rounded off, you just put that as important. You have to remember that, not important I can say. Remember those. Write a problem, 2015 NEET problem. In a PN junction diode, the input signal of 10 volts. In a PN junction diode, the input signal of 10 volts is as shown in the figure. Then find the output signal. Across the RL. Find the output signal across the RL. I'll draw the signals and then you have to identify the answer. Tell me what is the answer? ಏನೋ ಉದಯ್ ಎಲ್ಲೋ ಹೋಗಿದ್ವಿ, ಏನೋ ಯೋಚನೆ ಮಾಡ್ತಾಯಿದ್ವಿ ಫುಲ್ ಡೀಪ್. Which is the output signal there? 2015 question. Very easy, don't think much. Very easy. First identify which rectifier that is. How many diodes are there? One diode, nothing but which rectifier? Half wave rectifier. Half wave rectifier will rectifies what? Only positive half, only half signal. It is in forward bias, so only it will rectifies only positive half, nothing but this dashed line indicates that as a time axis here. So this is a negative 5 volts and then this is a positive 5 volts. Now you understand the structure. Whenever I continue like this, then you can understand easily. This is my signal now. So this is a half wave rectifier, nothing but only it will rectifies only half signal, that is this is a half signal we have taken. That's it. So which option is the correct answer? First option. That's it. That's the previous NEET question, 2015. Did not understand that? You understood, right? Then why you did not get the answer? Huh? Input nothing but whenever that is reversed, at that time obviously it will be in reverse bias. Diode tilt ಆಗಿದೆ ಅಂದರೆ ಆವಾಗ ಏನಾಗುತ್ತೆ, ರಿವರ್ಸ್ ಬಯಾಸ್ ಆಗುತ್ತೆ. You understood? Any confusion is there? I hope you understood whenever I continued the wave. Yes, so that is like a AC signal only. Which signal? That is a square wave. I said the types of the waves also. This is a square wave. So here only one diode is there which is in forward bias. When it will be in reverse bias, nothing but whenever they have connected like this, that is in reverse bias at that time. At that time what is the answer? Which is the correct answer? Fourth option will be the correct one. Clear? Now this one is a forward biased here. Whenever it is a forward biased, at that time it will rectifies only positive half cycle. So only I have taken only positive half cycle. So answer is this one. Clear? That is about the simple problem. Only that question came on the rectifiers. That's it. Nothing else. Then next one, next problem. The applied input AC to a half wave rectifier. The applied input AC to a half wave rectifier is 60 watts, and the DC output is 20 watts. Find the rectification efficiency. Find the rectification efficiency. First question. Next question. Calculate the value of power efficiency. Calculate the value of power efficiency. Understand the question first. ಅಮ್ಮ ಊಟ ಮೇಡಮ್ ಏನೋ ಫುಲ್ ನಿದ್ದೆ ಮಾಡ್ತಾಯಿದ್ರು. What is the rectification efficiency? How much? 33.3. Yes, sir. 1/3 you will get. What is the power efficiency then? That's important. Little tricky question. See that what is the question given? The applied input AC to a half wave rectifier. That is important. They have given about the half wave rectifier. Applied input AC to a half wave rectifier is how much? 60 watts. Nothing but input power is how much they have given as 60 watts, and DC output is how much? 20 watts. Then they are asking about the rectification efficiency. How much rectification it is doing? Nothing but output power by input power. That will be how much? Obviously 1/3 into 100, nothing but 33.3%. Next question is they are asking about the calculate the power efficiency. So how much? Anybody got the answer? No, 66.6. So here what will you get? Nothing but you will get first of all rectification efficiency. Everybody know that rectification efficiency. Input AC is how much they are giving? Power of the input AC 60 watts, and then output DC is how much? 20 watts. That is about the powers they have given. Now rectification efficiency nothing but that is a very easy, that is P output by P input into 100%. P output is how much? 20 by input is how much? 60 into 100 will take. That is how much you will get? 33.3% you will get. That is the first answer. Everybody will get the answer for that. Yes, you got that? Yes. The next question is power efficiency. Power efficiency. In this even formula is what again? P output by P input only. But in this it is very important that which rectifier they have given. I have given full cycle of input, but half wave rectifier will take only how much? Only half of the input signal. Half of the input signal nothing but P in by 2 you have to do. You understood, right? So it is not taking the total input signal. It is taking how much signal? Nothing but only half of the input signal. Why it is which rectifier here? Half wave rectifier. So only here how much you will get answer as 20 by 60 by 2 nothing but how much? 30. 2 by 3 nothing but 0.6, 0.66 like that you will get. So your answer is 66.6%. That is the efficiency you will get. Instead of half wave rectifier, for example, they have given the full wave rectifier. Then what's your answer? Again 33.33 only. Clear? That is what you will get. Actually, full wave rectifier means they will not give in that much of smaller values. They will give near to 80 like that. Nothing but 70, above 70 like that only they will give. That is about the half wave rectifier. Next, Zener diode. Zener diode. Write the reason also why we have taken P in by 2 there. What is the reason? Half wave rectifier, it will take only half of the signal, that's it. Next one is Zener diode. So what Zener diode will do? What Zener diode will do? Any idea about that? Zener diode will be used as a regulator, voltage regulator. What regulator will do? What regulator will do? In the name itself it is there. Any disturbances is there in the input power, whatever the input signal, that is finished. AC is finished completely in the rectifiers only. We again come to the DC only, DC input only we are taking here. So in my DC input signal, any fluctuations are there. Nothing but whenever you might be get high power and then low power, like that we will get fluctuations in the power. So that will be regulated by the Zener diode. You might be seeing the stabilizers in the fridges. Nowadays it is coming inbuilt stabilizer they are giving. Otherwise they will give the stabilizer outside only. You might be seeing that V-guard stabilizer round one like that. So that what it will do, nothing but it will have the Zener diodes inside. So what that Zener diode will do, nothing but it will regulates the fluctuations in the input power and then it will send a constant output. Now my output should be constant here. Whenever I have taken the input, this input is variable input I will take, nothing but I am giving high power and then low power, high power, low power like that. But by the Zener diode, what it will do, nothing but it will regulate the signal and then it will send constant DC to the output, constant output voltage it will send here to the load resistance. Load resistance means I said already, load resistance might be fan or TV, whatever it might be in the electricity concept only. Load nothing but we are just taking the extra resistors there. Extra resistor nothing but a device which is having some resistance, that is about the load resistance here. Now here whenever I just vary this input signal, at that time this is a variable input signal. This arrow mark indicates on anything. Whenever you take the capacitor, arrow mark on the capacitor, otherwise battery on that arrow mark, otherwise resistor arrow mark, in some of the circuits you might be get that. Whenever they said arrow mark nothing but that is variable. Here my input signal can vary, that is obviously DC signal only. Why? Because we have taken DC battery only here. So my input signal can vary. By taking that variation, what Zener diode will do, nothing but it will give the constant output voltage. So whenever you draw the VI characteristics of the Zener diode, how it will come, nothing but, and also you have to mainly remember that the Zener diode is a special type of PN junction diode that is heavily doped. Heavily doped PN junction we take, that is just act like a Zener diode only. And also what this Zener diode will do, nothing but it will just regulates the input signal and send you a constant output signal. And one more thing is, this Zener diode will operate only in reverse bias. Nothing but it will operate in forward as well as a reverse bias. But whenever it is operating in the reverse bias, then only it will act like a regulator. If not, if it is acting in the forward bias, at that time it is acting like a just normal PN junction diode only. I said this is also PN junction diode only, but what is the difference for that and this? Heavily doped. This is a heavily doped PN junction diode, and also whenever it is operating in the reverse bias, at that time it will act like a regulator. Whenever it is operating in the forward bias, then it will act like a normal PN junction diode only. So that is about the Zener diode mechanism and all. Then what I said, what it will do? It will take the fluctuations and then it will send the constant output. I said it will operate in the reverse bias. So whenever it is operating in the reverse bias, then what happens, nothing but yesterday already PN junction diode graphs we have seen that. In the reverse bias, we were having the graph like this. Correct? But now for the Zener diode what happens, nothing but I said voltage is constant or variable output voltage? Output voltage constant, input voltage is variable, output voltage is constant. Constant nothing but I will get exactly straight line like this. So this is the breakdown voltage where the current is increasing, that should be always constant value. Whereas if you see the yesterday's diagram, whenever you see the PN junction diode reverse bias diagram, at that time you might be get the diagram like this. I said that after the breakdown voltage, how much voltage here? 25 or 35 volts. For the case of germanium that is 25, for the case of silicon that is 35 volts. After that, whenever I increase the little bit of voltage also, we are getting more current, like that I said. But here we are not increase any voltage here. After the breakdown what happens, nothing but immediately the current will increases like this. Nothing but here what is the meaning of this, nothing but whenever you see this straight line, this indicates that my voltage is constant here. The voltage is not changing. The main motto of Zener diode is that one only. What it will do? It will give the constant output. Even the current is changing here. Current is increasing, but the voltage is what here? Constant only. So you have to mainly remember that Zener diode is a heavily doped PN junction diode, and also in the reverse bias what it will do? In the reverse bias it will just act like a regulator. In the forward bias it will act like a PN junction diode, and also it will take the fluctuations in the input signal and sends a constant output signal. Whenever you could just see the VI characteristics of the Zener diode, it will be there like this. Whenever you come to the reverse bias, it will operate, I said already, only in the reverse bias. If not, if it is operating in the forward bias, then it will act like a PN junction diode only. Then here, whenever I reach the breakdown voltage, after the breakdown voltage, it will not increases, voltage will not increases. Voltage will be constant only, but what happens here? Current will increases. This is I. This is I in microampere, obviously reverse bias nothing but. Here voltage will be there, and then here I is in microamperes. Now what happens? Once I reach the breakdown voltage, immediately my current is increasing. Current is increasing, but voltage is constant. That is what the Zener diode will do. Okay. Now here whenever you see this circuit, you have to find out the Zener voltage and then Zener current also. What the Zener diode is taking how much current here? IZ. You have to find out that IZ values also. This question also asked in the previous years, directly formula based. Now here, whenever you see the first loop, if you apply the KVL there, what will you get? I said already, Zener diode is just like a resistor only, I said. Diode is nothing but it is not a battery, it is just like a resistor only. You just consider this as a smaller resistance here. Clear? Now you apply the KVL in the first loop, tell me what is the voltages you will get. KVL nothing but what you will get? Sum of the voltages equals to how much? 0. Now input is how much here? I am starting here, then we are going negative to positive. What will you get here? Plus V in, and then in the resistor minus I into R. Now you are coming into the Zener diode. You don't take the positive polarities of the Zener diode. I said this is like a resistor only. So what is the voltage through the resistor here? Minus Vz is equals to 0. You are understanding, right? Whenever it is a battery, then you have to think, okay, this is a negative terminal, this is a positive terminal. I said it is just like a resistor only. Okay, Shreyas. Good morning, Shreyas. Like hen only you are sleeping. So here, sit properly first. So here I have taken the resistor. In that resistor, what is the voltage we are having? Vz. Across the resistor, potential decreases or increases? Amma, close. Chalo, mate martini. Yenaithe ellarige? Suddenly you are off. Not now only, from the rectifiers onwards you are off only. But in resistor, what happens? Potential will decreases or increases? Why we are taking minus here? Oh, same direction, adukane minus tagonta idva. Same direction illa, potential decreases. Across the resistor will take the potential always. It will draw some current. So that due to that loss only we will take it as a minus IR. Ellaru idara? No, you are like a Brahmanandam only. You just, no, I have to tell yeah, like that. Then only you will wake up. From that time you are sleeping only. You are sleeping, and then when she will leave the class, already 12 ಆಯಿತು ಯಾಕೆ ಬಿಡ್ತಾ ಇಲ್ಲ, ಇದೇ ಪ್ರಾಬ್ಲಮ್ ನಿಂದು ಫಸ್ಟ್. Just draw the circuit, I will explain that. Derivation is there. Draw the circuit. मोइन सर आए? कौन भी नया है? रघु सर भी? हाँ, तो लिखेंगे, नोट्स लिखेंगे. Draw that circuit. ರೆಡಿ ಇದ್ದೀರಾ? ಏನು ಶ್ರೇಯಸ್, ನೈಟ್ ಔಟ್ ಮಾಡಿದ್ಯಾ? ಪ್ರಮೋದ್, ನೀವು ಮಲಗಿದ್ದೀವಾ? ಶ್ರೇಯಸ್ ಇಲ್ಲ ಶ್ರೇಯಸ್ ಅವರು he is wake up means Pramod also will be like that only, no? How can you sleep without Shreyas? Right, that xenon diode is a special type of PN junction diode. Zener diode is a special type of p-n junction diode and which is heavily doped and which is heavily doped. This is heavily doped. The next point, Zener diode will act like a regulator or stabilizer. Regulator or stabilizer when it is operating in reverse bias. When it is operating in reverse bias. Underline that, important. When it is operating in reverse bias, underline that line. Next point, if it is in forward bias, then it will be like a normal p-n junction diode. Then it will be like a normal p-n junction diode. Next point, the output of Zener diode is constant even there is a increase in current. Draw both the diagrams. What is the difference between the symbols of p-n junction and then Zener diode? You will get a Z shape here. Negative terminal will be N type, will be the Z shape. That's it. आप